My name is Brendan. Sorry if my voice doesn't sound the greatest. I have the flu right now, but we will get through this. I'm presenting ARQ protocols, and so we will be looking at the differences between stop and wait, go back N, and selective repeat protocols. But first, what are ARQ protocols? ARQ protocols stands for Automatic Repeat Request. So these protocols are put into place to ensure reliable data transmission by detecting errors and requesting retransmission of either lost or corrupted data packets. So when the receiver detects an error, it lets the sender know in one way or another, as we'll see, that the packet it received or didn't receive was not correct and that a retransmission is required. And so there's a few different ways to do that. The first one we'll be looking at is the stop and wait protocol. Stop and wait is the first protocol we'll be taking a look at. It is the simplest of all the protocols because it is very straightforward. So the sender will send a packet, so this would be packet 0, to the receiver, and it will just send the one packet. It'll wait until the receiver responds, hopefully with an acknowledgement, and then once receiving that acknowledgement, it'll send the next packet, packet 1. And that will continue with acknowledgement 1, and so forth, until hopefully all the data has been transmitted successfully. Now, if we have, say, packet 2 comes down here, and it does not properly reach the receiver, then the receiver will not send an acknowledgement back. It will just send nothing. And so eventually, time will come and it will resubmit packet 2 again after waiting for the timeout to occur. And if that's received, then we will have acknowledgement 2. Now, as you can see, this is pretty inefficient, but it is really simple. It sends one at a time, and it waits for the acknowledgement of that packet that it has sent. But there's a lot of space up here and in between sending packets where the sender's not doing anything. The receiver's not doing anything. It's simply just waiting for this single acknowledgement. And so that's one of the downsides of stop and wait, is that it's not processing packets efficiently. It's going one at a time very meticulously, which is nice, but there's a lot of downtime where neither are doing much, when they could be processing more packets. And so that's something we'll see in the next section, which is go back N. Okay, so for go back N, we see something a little different from what we saw in stop and wait protocol. Now, go back N uses a sliding window, so the sender can send multiple packets before needing acknowledgement, and that allows it to be a lot more efficient with a lot less downtime than we see in something like stop and wait, where it can only send one at a time. So if the window is 4, it'll send 0, 1, 2, and 3. And as the receiver receives them, it'll send back 0, acknowledgement, 1 acknowledgement, 2 acknowledgement, and so forth, as long as data is properly being transmitted between the sender and receiver. Now the N in go back, N, refers to this window size. So in this case, it's 4. But what happens if 3 is not properly received? Well, by the time it gets to 3 with window size of 4, it'll also be sending 4, 5, and 6. Now, if 3 is not properly sent, the receiver can't go forward with 4, 5, and 6, even if those were properly received by the receiver. So instead, it's going to let the sender know, hey, I didn't receive 3, so the last thing I received was 2. When these duplicate acknowledgments are sent, that tells the sender that a packet was dropped or came in corrupted or something along those lines, and it needs to retransmit. So unfortunately, in go back N, these packets here, 4, 5, and 6, might as well have not been received because the sender is going to have to retransmit everything from 3 on. So it'll send 3 again. It'll send 4 again. And it'll send 5 again. And it'll send 6 again. And as long as those are properly received, we'll get acknowledgement for 3, acknowledgement for 4, acknowledgement for 5, and so forth. And so we can see that this is a lot better of a system than stop and wait. It allows for a lot less downtime over here. You know, these gaps are a lot smaller than they were in the stop and wait protocol because we're able to send multiple packets using that sliding window method. However, the downside and the little bit of inefficiency that we see here is that regardless of whether the 4, 5, and 6 packets were received properly, if 3 wasn't, those still need to be retransmitted as it goes in order 3, 4, 5, and 6. We'll see a workaround in that in the next part with the selective repeat protocol. Okay, in selective repeat, we're going to see a very similar setup to the previous one with the go back N. So in the same style, it's a sliding window. So the sender can send out 0, can send out 1, can send out 2, and it can send out 3 to the receiver. And then the receiver will acknowledge, acknowledgement 0, 1, 2, and so forth. Now, we'll put it in the same situation where 3 is not properly received, but because it's that sliding window, it's still going to send 4, 5, and 6. Now, the thing with selective repeat, it doesn't need for the receiver to send another acknowledgement 2. The receiver can go ahead and send acknowledgement 4, acknowledgement 5, acknowledgement 6. What is in place for 3 in order to get that packet resent is going to be a timeout period. So if we have a timeout period for 3 here, by the time it gets down here, if there hasn't been a received acknowledgement for 3, the sender is just going to resend 3 again. And hopefully it'll get an acknowledgement from that packet. And so what we see then is that we're able to do this really efficiently because we don't have to retransmit 4, 5, and 6. It can be asynchronous and allow for the receiver to just reassemble 3, 4, 5, and 6, even after not receiving 3. And so we skip the little bit of inefficiency that we saw in the previous go back N, where it doesn't have to retransmit all of the packets beyond the one that it has not received or received incorrectly. So only the lost frame is retransmitted. Everything else is stored. The downside to this is that it's a higher memory cost because it's having to store 4, 5, and 6 while it waits for 3 to be retransmitted. And so we'll kind of look at an overall comparison here in a second of the 3 and kind of see where that efficiency and complexity kind of lie between the 3 of them. So to summarize, stop and wait is slow, but it's simple. It's easy to implement. And go back N is efficient when it works, but it wastes a lot of that efficiency when it has to retransmit packets that might have been received okay. And selective repeat is a very high complexity with different timeouts for individual packets, but it's able to reassemble and receive and acknowledge packets out of order. And both of those use the sliding window method, whereas stop and wait simply only has a size of 1. There's different uses and there's different benefits to each method, but this has been just kind of a nice overview of each of those different methods, how they kind of work, and yeah, thanks for watching.